notation yet again, okay? And I want you to remember our rules from last chapter. So what were the rules? If your bases are the same and you have exponents, what did we do? We add them together, right? So this would be a to the 10th power. What was the rule when we have the same base and there? And we subtract them. Very good, because that's going to come up again today. Okay? All right. So next slide. So yesterday we talked about when you could add and when you could subtract. What did we say about that? They have to have the same exponent. So what's wrong here? They don't have the same exponent. So think about what we did in the warm-up. Are we able to change it so that we could possibly get the same exponent? Say that just a little louder for me. Okay, now remember, the rule if we were adding these two together is that they have to have this the same. Okay, what we just did a second ago was I did this, or something similar. I don't remember what they were. Those were multiplication, right? This is an adding problem. So what do you think we need to do? Listen. Could I change where the decimal is? How would that help me? Because it would change the exponent. And what would I want the exponent to be on both of them? The same thing. Yes, Nora, were you saying something? It's not technically in the right form anyway. You are correct. Okay? All right, so with her saying that, maybe this is the one we want to work with then. How could we change that one so that we now have 10 to the 4th? Catherine? Move it over to the right one time. So it's going to go from here to here. Move it over to the left one time. So move here. Okay. And so that would give me the number 0.09 times 10 to the 4th. Agreed? Okay. Now, we could either do that or we could mess with this one here and get it to change to a 3. Doesn't really matter which one you go with. You want to stick with this one? Okay, that's fine. So 5.3 times 10 to the 4th. We have all of that plus all of this. Okay, so now what can I do? I can add 5.3 and 0.09. What would that give you? 5.39. Follow me? Times 10 to the 4th. And then you have to make sure this is in scientific notation form, is it? Yes, because this right here is between 1 and 10 times 10 to the power. Yes? Why did she move it to the left? Okay, so remember, 0.9 times 10 to the 3rd would be a very large number, right? Because it's a positive. So it would be 1, 2, 3. So it's really the same thing as 900, but we wanted the exponent to be a 4. So if you start here and you go 1, 2, 3, 4, then that's what your new number becomes if you want a power 4. You just have to manipulate it to get the powers the same. Okay? Anybody else before we do the next one? Okay. So take a look at the next one. Now, this one's different because they're both in correct scientific notation form, right? They both are fine. Where this one, we're kind of like, well, that's not even in the right form anyway. So what do you want to do here, Eric? You want to make bigger numbers smaller, so you want to manipulate the 5? Okay. Oh, Catherine's shaking her head now. She does not like that. What's wrong?
Well, he said that he wanted to make 6.8 bigger.
He said he wants to make the power of 10 smaller on the 6.8 because he thinks it's easier to do smaller or bigger.
Oh, I thought he was like, he's going to move the 6.8 one time over and so it goes bigger.
Okay, so you're fine. Okay, Catherine's fine. Jeremiah.
You should change both of them.
You want to change everything. What do you want? You want to change both? What do you want to change?
Make the first exponent bigger, the second one smaller.
Okay, could you do that? Sure. So, are you guys seeing there's lots of options here? You guys can do different things. I don't know which one would be easier. I probably wouldn't want to have to change both of them. That would just be neat, but that doesn't mean you can do it if you want. Okay, let's just start with that one again, just because. So think about what this is. This is really 6.8. This is really moved out 5 times. 1, 2, 3, 4, 5. So here's what the number is currently. And I want it to have what exponent? A 3. So I can match the other one, right? So 1, 2, 3. So this is really 680 if I do it this way. So then you kind of have to decide which one you think is easier. Can you add these two together? We should be able to now, right? So I have 680 plus 5.4. So that is going to be what? 685.4 times 10 to the third. What's wrong with that? It's not under 10. Good. So I still need to move my decimal point. Bingo, bango. 2 more times. What's that going to do to that exponent? Increase it to what? To a 5. Okay. So now hindsight, what should I or could I have possibly done that might have made this one a little easier? Maybe if I would have moved that first one to a 5, then I wouldn't have had to change it here. But do we get the same answer regardless? Sure. So, like I said, you just kind of got to pick where you're going to start. Okay? All right, ready for this next one? Let's look at number 3. Number 3 starts subtraction. What would you like to do here? And room of silence. Pick on who? Oh, you want me to pick on Jake? Okay. Yes, Jake. Oh no. What do you want to start with, Jake?
I guess the 11.7.
You guessed the 11.7. Okay. So what would you like me to change that power to? Good. And then you can make this a 5. Good. So, oops, I did it wrong. 1.17 times 10 to the 5th. Good. We just took this and moved it over one more. Yeah, it was easy, right? Okay, so now I can subtract my numbers. So I have, somebody calculate that for us. What's 13.5 take away 1.17? Okay, thank you. What is it?
No, it's 12.43.
3? Okay, times 10 to the 5th. Okay, what's wrong with it now? It is not in correct scientific notation, so what do I have to do, Hassan? Good, move that decimal point over one more. So what's that going to do to my exponent? Make it one bigger, so it's 10 to the 6th. Okay? All right, I want you guys to go ahead and try number 4 on your own, and let's see if you're getting this. Okay, so which one did you decide to go with, the 8 or the 6? Most people did 8. Now, if you went with the 6, that's fine too. You can go with that, whichever one. All right, so Jeremiah, what did you do? You like changing them both. You're so funny. All right, who just changed one of them? Who can I pick on now? How about I pick on Jason? Jason, which one did you change? The 6th. Okay, so what did you change this to? What did you change? Oh, you changed them both to 6? Yeah, so what did you change this one to?
0.0529.
Okay, so we moved it 1, 2 times, and then we have this one. So Jason, what did you get when you subtracted these two? Times 10 to the 8th? Are you sure? No? That wouldn't be right, because 9, take away this, would not be 4. Whoopsies. Okay, what do we get? Can somebody do that for me? Eric?
I got 1.587.
Times 10 to the 8th? Yeah, that looks right. 9, take away that. Is that what you guys all got? Did we get it right? Yeah, you could do it the other way too, and you should get the same answer, right? Even Jeremiah, with his weird way of changing them both. Did you get the same thing? Yeah, good. Okay. All right. Next part. All right, so what happens if they give it to you in a word problem? Yay! Word problems make us happy. Okay. All right, about 1.10 times 10 to the 8th bacteria live in the human body. That's really disgusting. If there are 2,000 spectators at a football game, how how many bacteria are living in the spectators? I know, right? Gross. Okay, so what operation do you know we need to use here? Multiplication, right? Okay, so you're taking 1.0 or just 1, you don't have to have the whole thing, times 10 to the 8th, and you're going to be multiplying that by 2,000. Okay, now what's probably going to be easiest here is going ahead and converting your 2,000 into scientific notation. So what would 2,000 be in scientific notation? So 2 times 10 to the third. Agreed. Okay, now once you get it into this form, this goes back to what I showed you from the beginning when we said like this. What do you do when you have the same bases and you're multiplying? You can add the exponents, right? This is all multiplication. There's no adding or subtracting in here. So you can just multiply it all. So you've got a 2 times a 1, which is 2, times 10 to the 8th, 10 to the third would be 10 to the 11. Done. Yeah, multiplication, division, way easier. Way, way, way easier. Okay? All right, so let's try this one. So again, this is all straight multiplication. I could write this in any order I want. So I could reorder it like this, and it's the exact same thing. Okay, so I need to multiply 2.5 times 6. What is 2.5 times 6? 15? Is that right? Times 10 to the what power? 10 to the negative 7. There you go. You're adding those integers again. Okay, and then is this in scientific notation? No. So I have to move my decimal point. And then think about, first of all, is this a really big number or a really small number? Small number. So imagine that you've got all those zeros over here and then a 15. And right now, the decimal point is all the way back here. Where do I need it? In between the 1 and the 5. So how is that going to change my exponent? Yeah, is it going to be a negative 8 or is it going to be a negative 6? Negative 6, good. See, I have to visualize it. So see, in my brain, this is, I think this in my brain, and then I'm like, ooh, they moved 1 too many. So I really need to be at negative 6. Okay? All right. Okay, let's look at division. And division is just as easy as multiplication because, again, we don't have to have like bases. Or exponents, I should say. We have to have like bases. So look at these two. This is like in the thing today where I said this. What do you do with that? Subtract them, right? And by the way, is it okay to have negative exponents in this unit? Yes, because scientific notation, that's okay. So that's even better. Okay? All right, so 3 divided by 4 is 0.75 times 10 to the what power? Third power. Is this a big number or a small number? Big number because of the 3. Okay, so if it's a big number, I need to really move this here. So think what they actually did. What'd they do? They moved it too many times, right? Because remember, this number would really be 1, 2, 3. It's really 750. So they really should have only moved it 2 times to get you back to here. Okay? So really this should be 7.5 times 10 to the second. Okay? Good? Here. Oh, that's a thumbs up. All right. So last one. What do I need to do with these? Subtract them. So 2 minus negative 3 is how much? 5. Positive 5, right? Remember? So this would be 10 to the positive 5th. And now I have what's 1.25 divided by 2? 0.625. Okay? So this is a really big number in real life, right? Because this is a 5. Which means that they moved it too many times. How many times did they overmove it? Once. So 6.25 times 10 to the what? 10 to the 4th.